All right, what's up, everybody? My name is Sky. Welcome to update number 2 for team audio processing. All right, so here we go. I'm going to jump right in and start talking about a big overhaul that we gave to the wave files themselves. Um, the beeps that these phones are using to speak to each other. Um, you'll notice right off the bat that there's actually a big difference, that they're like 10,000 hertz apart, which is pretty high pitched. These old pitches, these ones under 5,000 hertz, we were actually able to prove that they're in the human vocal range because Max was able to like squeak his voice and the phone recognized it as like a symbol. So I mean, I don't know. Maybe a baby cries and it gets in the way of this or something. But I'd be really surprised if anybody was able to make these new sounds that are above like 14K. These are, I mean, they're kind of like dog whistles. They're more high pitched. So they all need like ranges to operate in. Different models, different hardware, different mics and speakers. The room noise, the size, whatever, different things going on. Sometimes the algorithm that recognizes the pitch is off a little. It has a margin of error. And so each pitch that we're playing, each wave file that has a tone has to be listened for in a range that allows for this margin of error. But that's still far enough away from each other that the phone can differentiate the symbols as representing different things. So I mean, I don't know. I ran these tests a bunch of times and looked at the data and figured out what the phones on average could hear and what they couldn't hear, and tried to make these ranges as high pitched as possible based on what the hardware was capable of. Something I did find that was really interesting was that as I got higher in pitch, these acceptable ranges of error actually got narrower and narrower. That you didn't need to be as wide, which I thought was interesting. But yeah, we really are coming close to making these things subaudible, which is what we were going for when we started talking about this. We really wanted them to be inaudible, and then thought maybe that wouldn't be possible, but maybe that we could make them really close to that and make them subaudible. So humans are supposed to be able to hear 20 hertz to 20 kilohertz, which is sort of a ruse. By the time you're an adult, you really can't hear above 16 kilohertz. And this is sort of that thing. I'm sure most of you guys remember when you were little and you could hear the TV, the sound that the TV made, but your parents couldn't hear it. That's sort of what we're talking about. And that happens at 16K. So we're approaching 14. We're over 14 kilohertz, and that means we're getting close to that, which is kind of exciting. So this is really due to a big achievement we had, a big victory where we were able to double our sample rate. It ended up just being stupid, like usual. Some things in the library we weren't understanding. We needed to change the code around a little bit. But now that we have 44,100 samples, we really have a detailed image. So much so that actually before, at 22,000, we were actually not able to capture all the peaks and valleys of a sound wave. And so we couldn't actually even make these frequencies this high. But now we are able to, with the sample rate being, how fast the microphone is able to relay that data back, which results in that detailed picture. So there are some clicks and pops, but these are just resulting from the media player being recycled, and it's not actually the pitch itself, which really is inaudible. So we did something else that was really interesting too, and we changed how we looked at the kerning. Before, with the kerning, I thought it was rather clever, but we were just using the room noise. So every time the beep stopped, the program would put a -1 in the buffer between symbols so that it could differentiate between them. Um, and now what we've decided to do is scrap our hope for making a ternary data system and use the 2 symbol that we were going to use to do that and replace it with the room noise and the kerning. And this allows us to send those beeps faster and more accurately with more precision. You can see here's a dramatic example of sort of what our error would have looked like in a really bad case scenario. We're still getting what we're calling duplication errors, where a symbol is heard multiple times, but we're using an algorithm to try to filter that out, and we're getting better at it. But the big problem here is that it didn't hear one of those room noise created -1s. It didn't hear it, and as you can tell, because of that, it took some of the bytes out. It didn't hear the kerning, and so it thought, oh no, that must be an error. I'm going to get rid of these bytes. And the resulting data is very, very much not what we wanted it to be. Whereas in the new system where we made the kerning a 2 instead of a -1 based on room noise, it's actually a beep now that's being spoken, if you will. You can see that we're just left simply with the duplication error, and the data looks much cleaner. Okay, I'm going to pass it off to Jake, and he's going to take it from here. Thanks.
All right, so I'm going to be talking about some of the successes and the failures that we've had so far with our application. So the first big success thing that we got going in this portion of the project was we got a working version of our network, so we have multiple devices being able to talk to each other, working with the sound. We were kind of able to, well, we dropped in speed with our beeps per second, and then we were able to bring that back up to about 30. So it says a success, and I know that's where we were last time, but it was kind of a success being able to keep it where we were. And that's due to the new kerning that Sky was talking about. We doubled the amount of beeps that we had per second, so being able to keep that the same is definitely a success in our book. As Sky kind of touched on, we went sub-audible, and that was a big success for us in terms of the sound and the two devices talking with each other. Next was just a slight ability to go message detection and correction, having this circular queue, being able to recover lost messages and kind of fix what they heard and what they didn't hear was a big success in our book as well. And then being able to thread both the listener and the talker fully really increased our ability, as well as being able to increase the hertz of being able to increase the ability at which the listener hears. So being able to get more cycles in per second was a big success in being able to hear more of the data being transmitted. Problems, so now we're kind of facing a few underlying problems. One just being that we still have somewhat of a low accuracy, so and that's kind of perpetuated through a network like a graph would be. So if one phone mishears something, it's going to speak that misheard message to every other node in the graph. And when that happens, then you just get errors on top of errors on top of errors on top of errors, and then it's like this big game of telephone that doesn't work out well. So being able to correct errors as soon as possible, as fast as possible, is going to be able to really bring home this whole idea for us. So moving forward, we're going to be working on our accuracy. Our range is already well over 30 plus feet with the volume up, and that was kind of a problem when we came to testing. As you'll kind of see in the demo, we have two phones that are like right next to each other, and that's with the volume down, and that's so that we can demonstrate this network and be able to film it, because their range is well over 30 feet, and so to spread these devices out as far as possible and film it was really hard. So we have a really big range, and that's kind of a huge success as part of our network, bigger than we thought it was going to be. So our next step is really improving that listener, so to increase the amount of misfiltered and misheard bits, and then to do some sort of bitwise correction better, and to be able to recover from errors. And then improving the speaker, really, which is just to try and shorten the beeps versus how long they are. Right now, they're about 0.15 seconds, and so to be able to shorten that even more, which is definitely possible, and have our listeners still hear it. And then to maybe even increase the pitch a little bit more if we have time. Right now it's sub-audible, but it would be nice to go a little bit higher. And so then you're going to see the demo now of the device. And this is an example of three devices speaking to each other. So essentially we've got two phones right next to each other with the volume down, and you can see that one relays a character to the other, and then the other one re-relays that character to another device in the network. So again, they're close together because we had to turn the volume way down so that another phone wouldn't pick it up, and then we could actually demo the network working. So enjoy.
Hey everyone, I'm going to be talking a bit more about the networking aspect of this project, kind of some of the things that we set out to do and what we actually have accomplished so far, as well as some of the things that we've had to either put off or change for now. I want to start by saying that we are on track. Things are looking good. We are repeating messages, which is kind of the minimum viable product that we all agreed to have. If we got to that point, we would all be at least satisfied, which we are, so I think everyone's pretty happy with that. And honestly, I'm pretty impressed too with the range of it. That's farther than I actually expected, so that's actually pretty cool to me. Other good things, duplicate messages are being ignored. Basically, if somebody sends you a message that you just received, you won't display it again or retransmit it. This kind of prevents that scenario where somebody sends a message, it gets sent back to them, and they send it back kind of in an infinite loop. So where we are right now, that can't happen. We have user IDs added in. Basically, it's assigned to you when you open the app. You get one at random. And then also we have collision avoidance added in. That's kind of just by the nature of the project. Basically, we just don't let a phone transmit until it doesn't hear anyone else transmitting. And that pretty much works exactly how we expected it to. So those are all good things. On the other side, some parts have gotten either harder or pushed off to the side for now. One big issue, testing is hard for some of us. I know for me, I only have one phone, so I can't practically test a lot of this stuff in real life. I can make sure that it works on one phone and doesn't crash the program, but that's about as far as I can go. So most of it I have to kind of just be really careful and say that it works in theory and then have someone else test it, kind of. Apart from that, some changes, we decided to send whole messages instead of splitting them into packets for now. It's kind of just to save time, really. We've put our effort into other places. Splitting the messages up when they're small wouldn't really make a big deal, and we're not really testing this with pages of text right now, you know. Hopefully we'll have it added in soon, but if we don't, if we decide to allocate resources elsewhere, that'd be, I think, not a huge deal. Another problem we have is user IDs are not guaranteed unique, basically because we don't have anyone keeping track of the user IDs. Everyone generates their own at random. There's no way to be sure that two people won't have the same one in a chat room. With that said, it's pretty unlikely that two people would get the two same names, just based on how we randomly assign them. It's really unlikely, actually. But yeah, to summarize, I just want to say that things are going well, not only in this aspect, but in all of them, honestly. It's getting better every day, so I think we'll all be at least happy with what we have here. So thanks for your time.
All right, I'm going to talk for just a literal quick minute here about some difficulties that we've had since our last meeting. So I think in a lot of ways the challenges that we're facing now are kind of the same as they were before, but just sort of in a different light. We had problems before with being patient and communicative with each other, but now more so than ever, it's really hard to get in touch with people and to communicate properly. In a big way, in setting meetings, in creating itineraries and staying on the same page. And in a small way, it's really hard, it turns out, to solve problems that somebody else is having when that thing is not right in front of you. Furthermore, not only are you trying to describe a solution to them, but they're trying to describe the problem to you, and you might not even be understanding it. So that's definitely been a big roadblock, as well as just getting on the same page time-wise, schedule-wise, trying to do the same thing. And it's become really, really clear that the problem has shifted away from delegating the right task to the right person so that everybody's working on the right thing, and instead just everybody get as much done, and trusting that the people who are submitting work are doing so correctly and on time. So, okay, thanks.